Hi guys, my name is Syed Mohammad Hamza and today I'll be running through and explaining my code for task 7.3. So in this task, I had to create a setup which will allow me to check the distance with my ultrasonic sensor, and depending on the distance, the buzzer's frequency or duty cycle will increase or decrease. So first I'll run through the code and then I'll show you my setup and the experiment. So I'm importing the libraries of our Raspberry Pi, GPI or GPI in time. Setting the board, I have set the outputs to be buzzer is 32, echo is 12, and trig is 7. These are the ones which we use for. These are the ones which we get from the ultrasonic sensor. And then, okay, so I'm initially setting the trig to be 0, and I'm telling I'm doing the setup, so I'm telling the trig is the output and the buzzer is the output and echo is the input. Then after this, I'm setting the buzzer as the PWM port, and then after setting up and starting the buzzer, I initially started with 1, and then I have a method or function which will take in the value of distance, and it's called duty cycle. So because I'm changing the duty cycle, so that's why. So I'm checking if the distance is if is less than 25 and greater than 20, then return 20, and then so basically I'm just checking with all these statements what the distance is and returning those values. So basically if it's less than 5, it will go to 100, the maximum. And then I have a method called distance. So basically just check, it will print out checking distance, then it will make the trig output to be true. Then I'm settling the trig for 0.01 milliseconds, and after that I'm initializing start and stop, which are basically timed out time. So inside my while here I'm checking the echo and saying that if it's true, then start time. So basically this is the initial time, and then the second time it hits the sound that hits the sensor, it will be the stop time. So time. I'm checking those two conditions, and after that I'm getting the real time, basically the time from the first time. So basically stop minus start, and that is the real time which we are going to be using in our equation. And then I have distance. So basically to calculate distance, I got this number through the formula of speed equals to distance upon time. So basically you can calculate it using the speed of sound. And after this I am rounding off the distance value to 2 decimal places. I'm printing checked, and then I'm printing distance and then the distance in centimeters. Then after that I'm returning that distance from this method. And then inside my try I have I'm trying that first of all I'm making the output trig to sleep. So because just for 1 second, so each time the loop goes, it just sleeps for 1 second, and then I'm making the distance equals to the distance function, which will return the distance, and that will make my distance. Then I have a parameter called sound, which will be calling the duty cycle method and inputting the distance which I get from here into this method, and then the buzzer. And then I'm changing the buzzer dot change duty cycle from this sound value which I'm returning from this method. So whatever value is returned, it will go into this method and will change the duty cycle according to that. Then I am sleeping for 1 second, and then I have a keyboard interrupt basically, which will just stop the buzzer and GPI to clean up. So now I can just run my program. Also for my setup, I forgot to explain this, so I can just go through it quickly. So my ground here is connected to the ground of the ultrasonic sensor. My red wire is basically the positive, so that's going into the power outlet. And then I have created a potential divider so that I don't damage the Raspberry Pi's input here. This potential divider is also connected to the ground. I have a 1 kilo ohm resistor here. Trig is going to the 7th pin, yeah, and the echo is going through the resistor into the input. So now I'm gonna show you my setup. So now if I move the box closer to the sensor, the sound changes, and if I move the box even further closer to the sensor, the sound changes even more. Thank you for watching.